Hello, welcome back to Topper Machine. I'm Josh Topper, and today's job is for the sawmill. We recently put in the poles for the shed to get started on building the shed, and we ran into we knew this was going to happen. There is an issue with getting the tractor to the husk for the PTO. So we need to build an extension shaft for from the husk to the outside of the building. And then there'll be support bearings out there and everything, but we need a universal joint. And what I really wanted was these. But these are obsolete, can't get them anymore. I could only get one of them, and I'm just gonna hang on to this one for anything in the future, because it's just a standard 1480 universal joint yoke. So what I did was I bought two of these yokes. They're weld-on yokes for a tube, PTO, drive shaft tube, and these will work. But what we're going to have to do is build a sleeve that goes on here, gets welded on, and will go onto our keyed 2-inch shaft. And so we're going to start back here at the big Johnson saw, my big filthy Johnson, and with this piece of 4x2 DOM tube. And we're going to cut it off about 4 inches. Okay, so while the other piece is cutting, we'll get this one in the lathe here, and we're just going to hold it by about that much, maybe a little less. And what we're going to do is we're going to do the bore first. We'll face it, bore it, turn down the OD, and then we'll do both of them, and then put the 4-jaw chuck in and finish the other end, because we want this as concentric as possible. And as far as the bore goes, we're just going to bore it a little bit oversized, not a lot. Because we're going to make this a split collar. So it'll be a 2-piece clamped together unit when it's on the shaft. So we'll probably go about 1 thou oversize. That's looking pretty good. Okay, we've got our trusty boring bar in here. We're just going to touch off on the ID. We got a burr there from facing it. And I know I have about 40 thousandths on the ID here to work with, so I'm just going to creep up to where it starts to clean up. And we'll run our first cut right there, and then measure it, see what we got. So I'm just going to take a couple of quick measurements here. So on the side that it cleaned up and the side that it didn't, I've got about 35 thousandths to go. 45 there, about 40 there. So we're going to take another 20 and get as close as we can. We're just going to take a little at a time because we know the bore isn't perfect on this DOM material. And once we get it cleaned up, actually we'll take 25. then we can, we just got to get it to about 1 to 2 thou oversize. Okay, this time we got most of the way cleaned up all the way around, so I'm going to grab my inside mic and we'll measure the best surface and then finish this bore out. Okay, so this is where it gets a little tough, is getting the inside micrometer in there. Especially on a small bore like this. But I have more than one trick up my sleeve. Looks good right there. I've got about 18 to go, roughly, to be at 2 inch, but I want to be 2 inch 2 thou. So I've got the bore gauge set up. Let's just see. This is showing about 18 thou too, to get right where I need to be. So we're going to do that in 2 passes. All right, let's see how we did. It's like about 7 thou to go. And it's pretty consistent all the way through. So 7 thou. One more pass. Let's see how we did, if we did. I am actually about 1 thou under, and I'll tell you what, I'm not going to screw with it because we're going to get probably 2 inch TG&P for the shaft, so it'll be 1 to 2 thou under there as well. So that'll work perfectly. So we'll go ahead, turn the outside, put some chamfers here, get the LD where I want it, and then we'll move on to the next step. All right, just gonna take a look, see where I'm at. I wanna finish this end at 3.5, and I've got 213 to go. $75 to go. Perfect. All right, this end is all done. I'll go ahead and get it out of here. I'll grab the other one, rough that one out, or finish that one out for that end, and then we'll throw the 4-jaw in, indicate the body, and finish the other end. Okay, got the 4-jaw chuck up here, got them both roughed out, and I'll bring you in and we'll explain how the 4-jaw chuck works in good detail, because there's little tricks that most people don't know about these things. Okay, I hope this is visible, but there are little lines on the face of your chuck. And these are to help you locate your jaw, so you get a better starting point. And here's my part at 3.5 inches. I lined up this edge of the jaw here with the line, and we're not quite big enough. Won't quite fit, so I'll just open them up a touch more, and then we can start indicating. Just like that. So again, I'm just going to go around and kind of use that line to set all the jaws about the same. And there's a good starting point. Now I'll get the indicator and we'll fine tune it. Okay, I don't know how well that's visible on the camera, but we'll just see how far off I am, and I am a little bit. 0 there. I say that's pretty close. Actually, I could fine tune it just a touch right there. Looks good. Now, one more thing I always like to check with my 4-jaws is if the part is lined up, as in straight. So I just turn between the jaws here, and I'll run it in, and yeah, we got a little taper there. So there produces another problem. Let's just see if it does it on all of them the same way, and no, it does not. So I have to correct that. So there's that one. So we actually need to, we want this thing straight. Off just a touch. And then we'll have to re-indicate. See, that one's off. There, now they all track about the same, so now we get to check our outer round again, which, look at how much that changed that. So we'll get that trued up again and see if we can get this thing done. We'll call that good enough right there. Now I'll just sweep it again and make sure we're still pretty close. And you know, this, obviously I'm going overboard, but there shouldn't be a balance issue on this. It's only, especially it's only running 500 RPM, but look at that. A little bit there yet, but nothing to worry about. Okay, so as you can see here, I left a step. I wanted this a little bit bigger right here where we're going to bore in and then weld it all. We're going to take my round insert and just come in and put a nice chamfer or radius on that. Just make it look nice. And for strength. There it is. All right, so the next piece of this puzzle here is we need to bore in to this diameter. So this slips inside and then that'll get welded on, just like that. So we want a nice snug fit or very true, and then slip that in and we weld that. They'll be together, you know, just like that, and then get welded all the way around. So we'll go ahead and set our depth and bore that out. All right, let's see what we got here. This is very hot, so it will be oversized, which is perfect. Yeah, it'll just start. That's perfect. So we don't want it too loose, so I'm gonna wind up heating this up and slip it on here or throw this in the freezer before we assemble it, but I want that as snug as possible before welding so it don't move. So this is perfect. I'll just put a couple chamfers on there quick, and this one is done, except for the keyway. All right, this end is done. It was these yokes are made for a 95 thousandths wall thickness tubing, and I'm finishing out at 140, so a little bit thicker should give me plenty of power and torque transmission. I really have nothing that I can see to worry about here. I mean, this is a lot stronger than a piece of tube over a distance. This is just a shortened, it's just a hub, really a clamp-on yoke. So absolutely perfect. I'm gonna go ahead and get this one out of here. I'll throw the other one up, finish that one up, and then we'll move over to the slaughter and cut the keyways. All right, we're over here at the slaughter. I got her set up to cut my internal keyway, and this thing works great. What's even better now is with the part, the way the shape is, that'll flood our oil right in there where we need it. So let's get cutting. That measures out good. We're done with that keyway. I'll cut the other one and then we'll move on to the next steps. All right, we're over here at the Bridgeport and I got my slitting saw set up. I got it set up here just where I want it as far as the height and everything. And we're gonna come in and we're just gonna make our slit to start. We're gonna have to finish that on the bandsaw because obviously this won't go far enough, but that will get us in there. That'll give us a working position. And then we'll, once that slit's done, then we'll switch it up and do drill and tap and everything for the locking screws. All right, and this is gonna take some lubrication, so we're gonna put some anchor lube on her and hope this works. Okay, so the next thing we're going to do here is come in with an end mill, and we're going to go in till we clean up 100% and then an additional 1/4 inch of depth, and that'll be the counterbore for our screw there. And we're going to do 3 on each side. So we'll do the counterbore, and then we'll come in with our tap drill and drill all of them all the way through, and then do our clearance drill, and then run the tap in them all. So we'll do it all in one setup, just leave it in the vise just like this so we don't have to worry about it moving, just change our tool. All right, all of our tap drill holes are drilled. I'm going to switch over to the clearance drill, and we're going to actually drill in just past where our slitting saw was, just a little bit past, so when we split this the rest of the way, it opens up completely. We won't have any threads in this half, just in this half. So we'll go ahead and get that done. All right, now we're at the point of tapping, and I don't know how far we're going to be able to go with the tap. Looks like a little bit without bottoming out, but we'll just finish it, hand tap it. So let's tap these holes. One more thing for good measure, I am going to drill and tap where the key is and put some set screws, some 1/2-inch set screws. That'll give us the surest bet that nothing can move. Between locking it down to the shaft and locking the key, we should have a pretty rigid setup. So let's drill these holes and get this thing done. All right, let's pull this thing out and take a look. So I'm over here at the vise and I'm just going to try to chase these threads out a little deeper. Obviously, I think a longer tap is in order, and I'll probably order one and finish this off before I put it in service. But this is the shortest kind of tap handle I've got. These are made by 𝐟𝐨𝐫𝐿, and you can use a socket on them. These things are awesome. And it just grips on the square. Let me get this out of here and I'll show you. It's like a little drill chuck for a tap. And like I said, these things are absolutely awesome. Love them. And that might have got me enough, but I think I'll just get a longer tap finish these off before we put it into service. So next thing, we'll slit it open and then weld it to the yoke. Okay, so in order to finish that slit, I'm back here at the 𝐼𝐸 vertical bandsaw, and that slitting saw we used was 40 thousandths. My blade is 35, so that will give us a starting point, and I'll just be able to just kind of guide it right in nice and gentle and get what I need. So let's get sawing on this. There it is. I didn't slit it all the way, mostly because it's just, all it's doing is clamping down on that shaft. We didn't have to split it all the way, and this gives me a little more material for holding, just to be safe with that, welding that yoke to it. So that one's done. I'll go finish up the other one, and then tomorrow morning I'll get these all welded up and finished off. Well, it is tomorrow. Let's get these things put together and go ahead and get them welded up. Get this job done. All right, I got it set up in my rotary weld positioner. I think I got her about where I want it. So let's go ahead and TIG this thing up. Well, took a little bit of screwing around, but I got a pretty nice weld on there once I got her dialed in where I wanted it. So, perfect. This one will work. All right, I got one down, one to go. We'll get these done. The next time you see these, we'll be on the sawmill powering the mill with the extension shaft and all the other stuff I got to do to make that work. So, I hope you enjoyed the video. I hope you learned something from my build here. And, just because something is obsolete or unavailable doesn't mean you can't make it. This was a part that, the part that was available at one point was obsoleted. It wasn't going to work the best for what I wanted it for, so I designed and built my own, something far better, far easier to put on, just a better solution all around. Being a split clamp-on unit, this will last forever. Be able to keep it torqued tight, locked down, and it won't move. So this is exactly what I needed. I hope you enjoyed the video. Stay with us. There's a lot of cool stuff coming. Until next time, get out in your shop and get it done right the first time.